Hi team, so today I'm going to show you how to do a related rates problem. And what makes it a related rates problem is you're actually going to use implicit differentiation to solve a problem in which two variables are being changed or two functions are happening at the same time. Okay, so let's take a look at this. An oil spilled from a tanker spreads in a circle whose circumference increases at a rate of 40 feet per second. So we have a little circle, oil spilled, and the length of the circumference is increasing at a rate of 40 feet per second. All right, so every second it's increasing by 40 feet. How fast is the area of the spill increasing when the circumference of the circle is 100 pi feet? So the first thing we're going to do is translate this problem into something that we can manipulate mathematically. So the rate of change of the circumference with respect to time is equal to 40 feet per second. Okay. How fast is the area of the spill? So we want to know dA dt with respect to time increasing when the circumference is equal to 100 pi feet. Okay, so now we've just translated this problem. Everything is with respect to time because the rates are with respect to time. Rates are things changing over time. And the two variables, although they are separate functions that have their own variables, typically we define circumference in terms of r and area in terms of r, we have to be able to relate them to each other, and that's why these are called related rates. Okay, so I start these problems by writing down what I know in terms of formulas for these. So I know the circumference is 2 pi r, and the area is pi r squared, where r is the radius of the circle. Now, in order to relate these two, I have to be able to combine the two equations. So what I'm going to do is I'm going to solve for r for both of them, and then set them equal to each other. So c over 2 pi is equal to r, and then a over pi, square root of a over pi is equal to r. Now, it's actually positive or negative a over pi, the square root of a over pi, but because it's a related rates problem, we're only taking the positive square root. Okay, so now we can set them equal to each other to relate the two rates. C over 2 pi equals square root of a over pi. Now, we're going to need to take the derivative of this, so I want to clean this up a little more to make it a little friendlier. 1 over 2 pi c, so now we have a constant multiplied by a variable. Then we have 1 over square root of pi times square root of a. Okay, so I just rewrote this function. Once it's rewritten in this form, I can go ahead and take the derivative of both sides with respect to time. Now, it's very important that we are taking this with respect to time. We're not taking it with respect to x. We're not taking the derivative of c with respect to a. We're taking both with respect to time. Okay, so the derivative is 1 over 2 pi. And the derivative of c is 1, however, because we're taking it with respect to time, we have to write dc dt. It is implicit differentiation that we're doing here. On this side, we have 1 over square root of pi, that's your constant, times, that's your coefficient, times the derivative of this, which is the shortcut I taught in class, 1 over 2 root a. And remember, since we're taking with respect to t, I have to write dA dt. This gives us a formula that corresponds to the givens that we received up here. In fact, with So we have the dc dt right here, and the dA dt, that is our unknown, and we have this a. Now you might think, oh, this problem gives us c, and here we are asking for a, but we can figure out what the area is at this moment very quickly. So if the circumference is 100 pi, that means that the r is equal to 50, because 50 times 2 is equal to 100. That means the area at this moment is equal to 50 squared times pi, which is equal to 2,500. Okay, that gives us our A. And here we have dc dt, and with these two variables substituted, we can solve for dA dt. Okay. So now we're going to go back into solving these. So we have 1 over 2 pi times the 40 from up here equals 1 over square root of pi times 1 over 2, sorry, this is 2,500 pi, 1 over 2 times the square root of 2,500 pi, okay, times dA dt. And since dA dt is our goal, we're going to simplify this. It's a lot of algebra, but it's actually kind of fun. This is 20 over pi equals 1 over, now here we have a square root of pi, here we have a square root of pi. Square root of pi times square root of pi is pi, times 2 times the square root of 2,500 is 50, times dA dt. And solving for dA dt, dA dt is equal to 20 over pi times the reciprocal, because we're dividing both sides, pi times, I'm going to turn that into 100 over 1. These cancel out. That means that dA dt is equal to 2,000 feet per second. Okay, so the question was, how fast is the area of the spill increasing when the circumference of the circle is 100 pi feet? And now we have figured out that the area of the circle is increasing at 2,000 feet per second.